Hydrohalogenation of alkynes. Now you'll remember that with the hydrohalogenation, you're adding a hydrogen on one side and a halogen on the other. Okay, so our experimental observations are that if we have one equivalent of our hydrogen halogen, we get one halogen added and the double bond is preserved. And make sure we get the right number of carbons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. If we have an excess of our reagent, then we'll end up with 2 halogens added and no double bond. So the mechanism for this is interesting because it's a third order reaction. All 3 of these components are required. So what will happen is the electrons from this bond will attack this carbon here, and the electrons from one of the triple bonds will come up and attack this proton, and these electrons will go onto the halogen and will form this intermediate state. My little green dots are supposed to indicate partial bonds, and I said intermediate, but it's really a transition state. We of course don't isolate transition states, we just have evidence that they exist. And we get our final form here, where we've added a halogen here and we've added a hydrogen there. So this mechanism is supported by a couple things. The vinylic carbocation is not stable, so we don't see this kind of structure where we have a positive charge at the end of a double bond. That just doesn't happen. Okay. The next thing is that it is a third order it has third order reaction kinetics. The rate is dependent on the rate constant times the concentration of the alkyne times the square of the concentration of the hydrohalogen. So the radical addition of hydrogen bromide, this is when we have a peroxide in the mix and we have anti-Markovnikov addition. It produces a mixture of E and Z isomers. Remembering that Z is the same side, so this is our Z and this is our E. So this only occurs with hydrogen bromide, not hydrogen chloride or hydrogen iodide. So only see this with bromide. We can interconvert dihalides and alkynes. If we have an excess of our hydrohalogen, we end up with this. And then we can reduce this back with sodium amide and water. So let's predict some products. Okay, so here we have a terminal alkyne. We're treating with an excess of our hydrogen halide, and we're going to end up with 2 successive additions, and it will produce a, I wanted to put this in another color, it'll produce a geminal dihalide. So we'll get a chlorine here, and we'll get a chlorine here. So let's look at the next one. Here we're treating with an amide, and we've got chlorine. We're going to take off the 2 hydrogens that are in this position. So we've got this tail here has 2 carbons in it, and so it's going to look like this. Then we treat with water, so we're going to have a hydrogen on the end. I want to make sure that you count your carbons, that this is 1 carbon and that's 2 carbons. Okay, here we treat with an excess of hydrogen bromide. So we will get, we're going to get 2 bromines added. I'm going to number my carbons, 3, 4, 5. 1, 2, 3, 4, and 5. 4 has a methyl group on it. I've put that methyl group here. And the double bond, any double bond would be, there is no double bond. We're going to add the 2 bromines to this position right here in 2 successive additions. Okay, so here we're going to make an alkyl halide. No, we're going to make a triple bond. We're going to need to pull off hydrogens. We don't have any hydrogens in this position, but we've got a couple of very convenient ones here. And so we'll pull off 2 of these hydrogens and the 2 bromines, and we'll make, we're not going to do anything to the ring. Pull that off. And then there's a hydrogen. So there's only 2 carbons here. There's a carbon here and a carbon here, and that's what I've drawn. I've got 2 carbons. What reagents would we use to achieve the following transformation? Okay, so now we're beginning to get into synthesis problems. These are going to be multi-step. Let's see how we're going to do this. So my plan here is going to be to make a triple bond between these 2 carbons and then re-add the chlorides to my triple bonded molecule. So I'm going to treat with an excess of the amide in liquid ammonia, and then treat with water, and I will get the following compound. Again, we may need to count our carbons. We've got 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. When you draw these structures, start putting in triple bonds, it's easy to get kind of confused. Okay, so now we want to re-add the chlorines, and we're going to add that by doing an excess of hydrochloric. And that will add them here in the more substituted position.